Right, we're back. So, how we're looking, does that come back now? Alright, I think it started as another stream, damn it. That sucks. Right. Okay, so let's get back to where we were. So, guess I should have checked the code more before it crashed. Yeah, so we're testing on AMD right now, Across. I don't want to do... I guess it'd be interesting just to see where, after we've written the BVH code, how many spheres we can ray trace with this BVH on Intel as well as AMD, just to see what it's like. But I'm not sure how well it's going to do, to be fair. Oh, we added this. Damn it. I know what the problem is. Right. Okay. So we because we have two nodes per, you know. Yeah. So this node is technically unused because we bundle our nodes right next to each other in memory. And the root node only has one node. Do we need a root node? Do we need a root node? Like, it's going to be inside the camera anyway, right? I don't think we actually need a root node, so I might just get rid of it. Yes, the problem was the root node. We had its sort of sibling next to it. It just seems a bad idea. That was empty. It seems pointless to check against the world bounds, not gonna lie. Right, let's not do that, it's a dumb idea. Yes, the problem is it was linking to itself and causing an infinite loop. So let's reduce these numbers down by 2. Ask because my system with AMD latest code in the repo doesn't render anything. Huh. Really? I wonder why that is. Are you getting any printing? Oh, I did do the occlusion buffer. I think I've disabled that now on my local machine. Yeah, I do have an occlusion buffer. So maybe that's not... maybe that's being filled up wrong or something. Very weird. Seems to lock when creating an instance. Well, a Vulkan instance, really? Wow. Oh, good. Right, so what we need to do is we need to push anything. So like a tree, a binary tree. We need to... Yeah, I think that might be one of your... like a driver problem, maybe? Or... oh. Have you got the validation layers? Installed on your system? Because I feel like it's returning an enum that's saying like something's not supported. Oh, it should show up then in the... yeah, because we enable the layers. So it should show up. But yeah, you can definitely run the Vulkan cube. There's a Vulkan cube demo. I think you have to install it. Yeah, see if you can run the Vulkan cube demo. If you can run that, then it's something wrong with the program. Maybe. Or the configuration. I've got for the program, at least when it boots. So on this stack, we want to like, so you'll traverse down the stack, right? If you get a hit on the left, you'll go down the left, right? Then you've got to come back up, so I guess you'll push. So what's an interesting thing is we can avoid traversing all the way back up the stack one by one, because if we check the left and the right at the same time, we should be able to remember where's the previous place on the stack where I actually hit something. Yeah, you could probably remember the previous place on the stack where you actually hit something and then just jump all the way back up. I think if we drew it in Milton as an example, rather than using our imagination. So you have a binary tree where, so these are the BVH nodes. So you traverse down the left, right? So this one is implicit. Yeah, this one's implicit. We always have a left and a, we basically just start off like that. These are just next to each other in memory. So maybe we should have one more layer just to make it simple. Oh, just to make it make sense, right? Okay. So you traverse from this one down to here, and you're checking. Okay, first of all, you check these two. I've hit this one, right? And I've hit this one. Then you check these two. You go down and check these two. I've not hit any of these. Okay, let's just say I've hit this one, but not this one. Yeah. Then I've not hit. Then you check these two. I've not hit these two. So you would then say, because you haven't hit anything, and now jump back up to the closest thing on the stack. This thing won't be on the stack because we didn't hit it, and we've hit. But this one is. So this one will be on the stack, and you can jump back up the stack to this node here, right? If not, it could have been that one, right? So that's interesting how we can jump up. Because we're checking two nodes at a time when we go down, we should be able to jump up and leap back. And that should hopefully save some in and out traversal crap on the loops, right? So hopefully that'll work fine. So we basically want to have a stack, and this just remembers where the previous, what's called the previous hit stack, previous BVH hit stack, and you're just remembering how to go back up the tree, and that's about it, right? So but you can also preset up the child index as well. So it's quite interesting. So you can be like, right, I've hit this guy. So you want to say Boolean hit left equal false. Boolean hit left equal true. Then you have a hit right. And then you have hit right. Something like that, right? So what happens is you have your next node. Now we should really have a left BVH. Damn it. Yeah. Yeah, so this should really just be like left BVH. Okay, or BVH left. Then this would be BVH right. So what you want to do is you simply just want to test okay, so what do you want to test? If you hit the left, your left or right could be a child. Okay, what's the way to think about it? Yeah, so in this particular case, we don't really care about the child nodes at all. They just tell us that we have reached the end and we should really traverse back up. So the test would just be like if so if we want to continue left, we just push if is well, like hit left. So if we hit left, go down the left. Else we've hit the right, only go down the right. So to do that, you essentially just advance the index like so. You don't do the stack thing, right? We don't do the stack thing like we thought we would. So instead, we're going to use a BVH index in the level. I was hoping to use like a level so we can sort of debug it better, but we could do a level thing, I'm not sure though. Let's just bump in closest hit BVH index, something like that. And rather than stack index, we'll say something like BVH index. Wait, that will work. Because BVH index will be the same for the left and right, which makes them the same level. So I can actually undo that. And it would be the level. So it's BVH index. That should be it. The left and the right code. So if we hit left, we just go to the left child. But if we hit the right as well, we want to make sure that, so if we've hit the right node, we want to make sure that we back it up on the stack. So you got your sort of BVH, what was it called again? Previous hit stack. So you do a previous hit stack and you back up previous hit stack index, and you back that up with a so it's your BVH left, and you get your BVH right. So you don't jump. So the interesting thing is these two might have both been a hit, and you've traversed all the way down here, and you know these haven't been hits, and this one wasn't a hit, but this one was, right? So you got to here. So rather than jumping all the way back up to here, you go in a step further, you jump in all the way over to its children and just checking the children. So it's able to leap. It's not going to go up here, up there, across, then down. It's just going to leap right to the next one. That's pretty cool. I think that's a good sort of, that's a good thing we've managed to do there. So if you've hit the right, you're literally just going to use the right. You're going to change the BVH index to the right one. And the other thing is we want to terminate if our BVH left or right. Well, we don't terminate. What's the way? How do we want to do this? We want to revert back up to So if we end up traversing, yeah, it's this one, isn't it? If hit left. And basically not a child node. Something like that. And then I guess we'll say if the right is not a child node. Right, so my one concern is... Alright, let's just say I'm not a child node. The right here. Something like that. Yeah, so we just say, okay, if BVH index is a child node, we just want to traverse back up the stack. But if our stack index, so if our previous BVH stack index, if that's got something, we just want to restore that. So you minus the 1, and then you basically just say BVH index is equal to that. Right, because we've said it's what its child was going to be. You jump back up, go to its children, and then else you're going to return false. You can set running to false and then end. So there's also another optimization you can make, and that is you can test you probably want to early out if your BVH test is like if you found a closer hit, you want to bail out earlier. But let's add that in just a second. Let's see if this runs. Oh shoot, what is this? No. When do we do an XOR again? Why do we do an XOR? Okay, we did a not on a boolean or something, wasn't it? Yeah, I can't. Yeah, there's something to do with this logic. Here, I think. Yeah. Oh, shoot. Right is child. I gotta fix that. I got a moment. My compiler's got a bug. Right, we need to fix that because I've encountered that one before. To do fix compiler bug. Yeah, something to do when you do an and you've done something a little bit on the right hand side. Don't do with the types. Is that really right? Maybe. Let's just double check it a sec. So it did a not. Does that still compile? Right. That's the one we want to comment out. There you go. Cool. Yeah, this is when you're doing and not it. You're notting a boolean, and it needs to change it to an integer because it's some SPIRV specific thing. So I think if you're not a boolean, it does it as well. Is that right? Yeah, something weird like that. Anyway, so let's just double check and make sure it's all fine. So the BVH left. We check if we hit left. So BVH left. Hit left is true. Sort that out. Yep. BVH right is that +1. Nice. Cool. If we hit the left, we traverse down the left. And if we hit the right, if we hit the right and the right is not a child, we back it up for next time. Else we traverse down the right. If we're trying to traverse down a child node, we try and revert back up. You know, if we have an index, we fetch the last one on the top of the stack. That's our new BVH index. And then we set is run to false if we've run out of things to go and check. So that seems legit to me, so let's give that a run. Fingers crossed it doesn't crash the stream again. Let's go. Boom. Excellent. So I'm seeing a slight problem. I'm not seeing a full traversal. For some reason. We're not seeing enough greens. We should be seeing 2 greens down here. We've seen 2 greens up there though. Why? Why is the question? Right, because that one links to 2, that one links to 4. Whoops. No, that's right, isn't it? Links to 2. 4. Oh yeah, I made the other one smaller by 1 pixel. That can't be why. Yeah, it's just made them more visible now. These ones more visible. These ones should be rendering. So we've traversed down the left. So yeah, we'll definitely hit the left. So you traverse on the left. Yeah, then you just go around here. Is running. Get the left. Just go through the left. It should be a child node this time, and the right would be there as well. And that would be a child node as well. You might have hit the left. Yeah, I don't see a problem with it. Should we try and isolate? Should we try and isolate it a bit? Should we try and say and if your and if your BVH index is not equal to 2? So that would, or not equal to 0, the first one, yeah? Huh. Weird. Now I'm not seeing anything. The whole thing when you skip a node or something. I don't know if it is that one. It could be that code though. But we just didn't display 2. So this is 2. So let's display them one at a time, right? If 0. What? Oh yeah, because that one's displaying the right hand side. Sorry. Yeah. That's the right hand side is a separate one. Let's display basically level 0. Level 0, perfect. And let's go down to level 2 only. No, it's not level 2, sorry. Yeah, that'll be level 2. No, yeah, that'll be level 2 for a specific set of nodes. These left 2 nodes here. But they're not showing up. Right, that's interesting. Why are they not showing up? So we're looking for BVH index 2. It's this guy here. We just would have jumped to it. It's on the left hand side, so it's got the priority, so it should just show. We should do a thing where we say or oh, I changed the Great Britain keyboard. Why did it do that? Right. BVH index equal to. Let's try that. It's still not showing them here. Just letting it through regardless. Which is super weird. Is it because is it because it has to hit the first node before the second node is hit? No. No, so the way it works is you hit, so this is the root node technically, it's an implicit one. These two sit next to each other in memory. If you hit this one, it will traverse down the left, and if you hit the right, it will store it on the stack. Stores that one on the stack. Or it stores the link to this one on the stack, the first one, because these sit next to each other in memory. Then you traverse down here. You check, you repeat again, you check if both of them hit, and if they do, yeah, then you repeat the same step again. So it should redirection is always the same, so I guess we could bring that out of the loop, not that it matters. Put that near this one here. Right. So why can't we traverse down far enough? We can always display a hit if it's 2. Wait, is it we were traversing far enough? With the bound. Like you should always go down the left. Basically, we do have print. We could just print from the GPU, right? So we could just do this, but we should isolate it to probably. Yeah, it's quite difficult to isolate to a particular pixel though. It'd be good if we had mouse coordinates passed into shaders, because then we could just print it at a mouse coordinate. But maybe not now. Yeah, let me try this out. We can debug it really easy. If x (200) and y equal 200. We're gonna just store y. Yeah, job's good. Whoops. Right, there's our white pixel. It's in the wrong. I need to technically flip it. Because the texture wants it flipped, but it's the correct coordinate we're dealing with. Right, so where's that white pixel? It's probably flipped. It's too far up. Bring it in by 100. Basically, I want to hit the box. Right. Yeah, so that's going to be inside the box. That white pixel there, yeah? So we should be able to follow how it prints out. So all we need to do is say if it's equal to 100, we can say if it's hit left or hit right. So GPU hprintf, we should be able to just say hit U, so be left or right. What else do we want to say? Is that it? Hit left. Oh no, we also want to say what one we tried to hit. BVH. Hit BVH index. Then just say, left and rights basically. So BVH index. So let's try this one out. See some lovely prints only for 1 pixel. Right. Here we go. So we've got BVH. They're both zeros? What? How did you manage to get left? To go left? Oh, we didn't handle, we didn't hit both. So we'll go down the right regardless. Crap. I just realized. Our hit left and hit right are only at the borders. Shoot. So this one is going to set BVH index to child or something. Just do that. Just put the child node thing on there. Hit right. Yeah, that makes a lot more sense now. So the problem is the hit left and the hit rights were not... Like, this is only if you've hit the border. We've hit the right as soon as we come into here. We've hit the right box as soon as we come into there, right? Same with that one. Hit left. That was the problem. Boom. Jobs are good in. Look at that. So we've got 2 levels of BVH. And we're able to traverse to the traverse code as well. Excellent. Excellent. Now there is another quick test we should be able to do. So there's another problem. You could have traversed your nodes and you don't bother needs to test anymore, basically. So we're going to test everything that we hit, which is not good. So we could have tested this one, right? And this one would have been a hit. And this one would have been a hit as well, or whatever. Or maybe a miss, because it's a leaf node, we missed it. So this was the last hit that we did. So we actually have a closest hit. So if you end up having to go and test this guy, or you want to look at the children of this guy, right? If this box actually was further away, if this box is further away than this hit, you actually don't have to test any of this anymore. So you can actually go back up the stack again. So what you actually want is another array of previous hit. You want like a child. Child index, and then you want another one which would be closest, or t min, right? So your t mins go there. So this way you can do a nice little check, right? So you've got so you only want to continue testing the boxes if the children, if you yeah, here it is. So child index, let's be like t min. So you want to call the t min of that right hit, right? Only the right hit. So where is t? So you probably want to store on the stack t min element. This one, yeah. So t min element, we just want to store it in there. And then what we can do is we can do a nice little check where we can just say, right, given this, so you want to say while, and then else, yeah, anyway, while that, if only you do a while else, or maybe not. Okay, if that is equal to 0, yeah, it wouldn't have worked anyway. So anyway, while that is true, take away 1. And if, but we only want to do this, providing that, yeah, we only want to stop if this is less than our closest hit so far. Is that right? It's not not good enough. Yeah, this closest hit doesn't make any sense. We should call it like border closest hit. Closest hit closest border hit level, something like that. Closest border hit. Wait, hold on. Well, that's the thing, or is that just memes? No. So basically, like, I think some new languages sort of do it, but maybe not. It's not really worth it, to be honest. And it doesn't actually compile out to anything. Like, yeah, if you used to compile out to machine code, you basically have to put another if statement in anyway. So it doesn't really reflect on what the computer actually does. So there are one or two cases where it can seem like it's useful, but it's not really. Yeah, it's a bit like a for else, you know, a for loop with an else at the end. You know, if this thing never runs, do that. But yeah. So basically we need to keep track of the closest hit depth. And this is another optimization to avoid us traversing down a tree that we don't have to. If the tree's massive, this is a big win, which we can have massive trees. So I want to write this out first because we can just copy paste this when we do our proper tree traversal algorithm. So the other win is this closest hit depth. If that's less, then the closest thing with the closest box we've actually hit against. Wait a minute, which one is it that we care about? So in case of yeah, it's really the lowest, it's really the leaf node. What is the closest hit leaf node that you've hit? Yeah, which in our case is like the border anyway. Yeah, so I'm gonna undo that border change we did. So if that's less than closest hit depth, then actually bother traversing it, right? So if you have, yeah, we're ignoring the leaf nodes right now. Right, so let's give that, oh my days, what is this? Oh, shoot. I hate this thing so much. BVH is the worst to write when it comes to doing basic blocks and loops. Right, so to end it, we're just going to set this to 0. Oh my days. So what is it then? I thought it was the break statement. I've got while loops. But does it not support a while loop within a while loop? Is that the problem? Yeah, my while loops within while loops are broken. Damn it. Right. Is it while loop within while loop? Yep. Because that's outside of an if statement. shoot. Well, I know I've got for loops. I know those work. Right, there's another HCC bug to deal with. While loop within while loop. To do fix while loop within while loop. Damn it. Right, so 4. Okay, here we go. Wait a minute. Oh, I expected an expression. Shoot. What? I have a serious time believing my for loop doesn't work. It's something more complex than that then, which is even worse. So here's another thing we're going to try. Just compile everything out. Oh, I hate compiler bugs. It's a while loop in a while loop, it just is. Right, okay. I've got to make it into a for loop. See, I can't even do the iterate backwards as well. That's another thing that's buggered. Yeah, because there's 2 bugs to fix there. And sort of empty init and expression, or like inc expressions. Oh, horrendous. Horrendous. It's a slightly different bug, but yeah, there's like 3 bugs basically. Have just become... Yeah, this is another compiler bug. Whoopsie. 3 in 1 stream, that ain't good. How are we going to get around this compiler bug? See, this is one of those things where it's like you can't expect a user to sort of understand the problems, these issues, you know, and get around them. But maybe they're smart enough they can do it, but still. Should really fix these. Right, that compiles fine. Bloody weird. Right, so we need to put like a... Oh, horrendous. Get rid of that. Okay, so the test is if that is less than that, then we break. Okay. Yeah, I really want this to be a while loop though. But anyway. Let's put that back as commented out. Cool. Right, fingers crossed it doesn't crash. So we've just added this if statement. So put tmin in there. Yep, then increment. And it should go back post decal. While that's greater than 0. Cool. Rightio, let's take that for a spin. Oh, you bugger. Am I kind of live? Is it still going? Right. I think I'll just call it there. My stream is dead. Right. Thanks for coming. I wanted to hear me. Have a good night. I'll see you all on Sunday. I'm gonna pack it in now. It's kind of late. Right. Have a good rest of your weekend. In a bit. Bye. Right, can I even turn my machine off?